Good morning. First off, just wanted to let you know, my name is Jason Schiller from UUNet MCI, and I have a bunch of background slides and some slides talking about how Shim6 works. So if you're familiar with this, go ahead and dive down into your email and get some work done. The other point I wanted to make out is before you phase out and say, oh, we're not doing IPv6, this is academic or esoteric. I just want to point out that IPv6 is important even if you're not running it today. There are a lot of people going forward with IPv6, US government mandates, Japan, China, some application developers. But the more important thing here is IETF is currently looking at IPv6 problems and protocols to solve them. And the RIRs are setting IPv6 policy today. And in 5, 10, 15 years, whatever you think the number is, at some point you're going to be running IPv6. And when you do, you're going to be stuck with the policies and protocols that they're developing right now. So get involved, make sure that we get useful solutions that you guys are going to want to run and operate in your networks, because it's easier to get them from the start rather than retrofitting what we have later. Wanted to go through a couple of slides just to talk about the size of the v6 routing table, just to give you an idea of how huge it is. And because of the size of the table, we're talking about consuming routing memory in the RIB and the FIB, affecting forwarding rate from FIB lookups, and also affecting CPU time in terms of convergence, SPF, RIB rewrite, RIB to FIB population. The other interesting point here is there's a lot of different predictions about the size of the IPv6 routing table. Some of the predictions talk about how big the routing table would be in terms of /128s, which surely isn't going to happen. They vary greatly. And the other interesting question is, when will v6 go prime time? And there's an ongoing debate about what that date is. Somewhere between 2016 and 2009 is kind of where the endpoints are. We also need to consider the speed of the Japanese adoption and the US federal government mandates to do v6 by 2008. One of the things that I've done in terms of looking at how big the v6 routing table is to go ahead and take a look at the v4 routing table and try and figure out what types of routes we see in v4. We basically see three types. We see aggregates, and we see two types of deaggregates. We see one type of deaggregate where a company got a small allocation, say a /24. A few years later, they outgrew it. They got a second /24. The two are non-contiguous, and they didn't return the first one. The second kind of deaggregation we see is where a large aggregate has been assigned, say like a /20, and that /20 has been divided up into discrete /24s and advertised separately on the global internet routing table. Possibly for traffic engineering, possibly because they have multiple stub sites that are not interconnected, hopefully because they're doing something smart. If you take a look at the Tony Bates-Sider report, we have about 160K prefixes in the IPv4 internet routing table, and we can easily aggregate those down to 112. That means that there's about 55K intentional deaggregates. And again, hopefully this is because people are doing something smart. So the question here is, if we move to v6 tomorrow with no growth and everyone does dual stack, how many v6 routes will we see? Well, we've got the current v4 routing table, 166K prefixes. We've got your internal deaggregates for IPv4, which for a tier 1 ISP is easily 50 to 100K routes. On top of that, you've got your IPv6 aggregates, where every autonomous system will at least have one aggregate. So pick your number, roughly 20K active ASs, 30K assigned ASs, somewhere in there. And then on top of that, you've got your intentional deaggregates. And if we continue to deaggregate like we are in v4, that's roughly 55K deaggregates. If you add to that your internal deaggregates for IPv6, which is at least one prefix per static customer, probably more than one for some of your multi-home customers. If you consider that most of the tier 1's ISPs do IP forwarding and hardware and have to be able to support large throughputs, we're easily exceeding the FIB limitations of currently deployed hardware. So how do we solve this problem? Well, one way is you throw hardware at the problem. You commit to scaling your router memory size and your CPU speed in order to support very large RIBs and FIBs. You commit to faster processors for the SPF. You try to find a way in software to optimize your FIB storage and your SPF processes. And you hope that the hardware-software solution is available, in my case, at least 5 years before widespread adoption, because it's going to take some time to test and certify the equipment, and also to replace deprecating equipment through normal refresh. It's going to be very hard to buy all brand new equipment just to support a service that's not going to generate new revenue. The other way to solve the problem is to try and minimize the deaggregation and only allow service providers to announce a single aggregate. You need to solve other problems like multi-humming and host mobility and provider independent space without putting deaggregates into the global routing table. The trade-off here is that information is lost. When you decrease the amount of routing state you have, you end up with suboptimality in the routing system. And you need to have some sort of forwarding plane mechanism to offload this functionality too. So Shim6 was basically an attempt to solve the IPv6 multi-humming problem without deaggregation. The idea here is you put multiple IP addresses on each end node. These are called the locator IDs, which actually locate where the node is on the internet. Apart from this, they've separated from the locator ID this concept of an upper layer ID, which is basically the thing that your TCP or upper layer protocol terminates on. So the idea here is you can have a host that has multiple sources or destinations, and those IP source and IP destination can change without impacting the TCP session, which is terminating on the upper layer ID. Part of the problem with this is that multi-home destinations have no ability to traffic engineer inbound traffic. All the traffic engineering is done on the source host. The current solution is documented in draft IETF multi-6, layer 3 shim 00 text. Basically, every multi-home destination has one IP address per upstream ISP. Multi-home destinations also require an upper layer ID. And you can insert a shim between the IP header and the TCP header that contains your upper layer ID information. So just a quick walkthrough of how this works. A host would do a quad A DNS lookup on a host name and get an IP address. He would pick one of the IP addresses that's returned from the DNS query. He would try to establish a TCP or whatever protocol is using session with that address. If it doesn't work, he'll choose another address. Once he finds a useful address, they start having their communication. If it's a TCP session, they make their handshake, they start communicating. At this point, both end nodes can signal that they're Shim6 capable. They can exchange a complete set of locator IDs, and at that point, or at any point in the future, they can decide to insert a shim, which will allow them to change your IP source and or IP destination without changing the information in the shim, thereby not impacting your session. So kind of a picture of how this looks. We've got a standard source with 3 upstream ISPs talking to a destination with 2 upstream ISPs. Builds his regular IPv6 packet, sends it along the wire. They start communicating. Once this happens, they can do the locator exchange, and they will send a complete set of locators to the opposite ends. Once the opposite ends have the complete locator set, then they can go ahead and insert the layer 3 shim. There's some discussion about what upper layer IDs to use, but right now it seems the best solution is to simply map your IP source and IP destination into your upper layer ID. Once you've done this, you can switch over all your sessions to use the layer 3 shim, and in the event of a failure, all you have to simply do is detect in the forwarding plane, either from one end or the other, that there's been an outage, and simply replace one of the addresses in the IP header. So one of the things that's fairly interesting here is how does traffic engineering work in this solution? And when I first started talking about V6 multi-homing, I thought the problem really was a lack of understanding about how inter-AS traffic engineering works. And at the last NANOG, I put together a talk about the different basic cases for how IPv4 traffic engineering works to basically try to use these as a case study for requirements for V6. And there have been previous attempts to document the inter-AS traffic engineering, and they kind of document a couple specific cases, but it doesn't seem like they got the whole big picture. And I thought that was really the problem why they weren't providing a solution. Well, it was then pointed out to me that RFC 3582, which talks about site multi-homing requirements for v6, that the word requirement doesn't actually show up in the document, and all uses of the word requirement were downgraded to goals. So it seems that this type of traffic engineering isn't really important for an IPv6 multi-homing solution right now. And there's a couple of reasons. The first reason is a lot of the network operators that are involved today mostly have consumer customers. Most of their consumer customers are not multi-homed, and they think that simple failover solves the problem for 90% of the internet. There's a strict focus right now on forwarding path failure detection. They think that this is maybe a harder problem to solve, and they're really currently only concerned with designing the protocol. And in the past, when I've jumped up and down and said, you know, we've got operational concerns, the response was always, there's no impact on the protocol. And I've talked to a few people after the sessions and posted a few things, and it seems that there are some impacts on the protocol, and people are starting to look into that at this point. The other interesting problem is site multi-homing versus host multi-homing. In IPv4, what we have is traditional site multi-homing, where your network is multi-homed. In Shim6, the multi-homing is done at the host level. So what you end up with is host multi-homing instead of site multi-homing. And there's some problem space here, because how do you add network-wide traffic engineering preferences to a host-to-host solution for Shim6? But there's also some other interesting side effects. Host multi-homing may be very useful for a consumer customer. Take a look at your average cable modem or DSL user that has a few PCs all connected to one shared broadcast domain. The only routers he has are his internet-facing cable modem or DSL router. The end user owns all the hosts and the network. The routing equipment that they have is typically fairly limited, and they don't want to get involved in the complexity of BGP for multi-homing. So from a cable modem user's perspective, Shim6 is great. You just put multiple IP addresses on your host and you go. But in a large-scale commercial network, it doesn't really fit the operational space very well. There's a large number of hosts. There's typically a complex routed network. And the end users who own the PCs don't usually own the network or the traffic engineering preferences of the network. So what is the impact of inter-AS traffic engineering on the Shim6 protocol? Well, in v4, a multi-home destination can influence routing into their destination on their inbound links. And in v4, the source network can constrain routing, not get full routes, or alter their IGP metrics to influence how traffic is loaded outbound on the network links. In v6, the multi-homing is all done by the source. The source has no BGP routing information, it has no IGP routing information. The only way we can get equivalent functionality is to somehow send additional clues to that source so that they know how to order the locator ID set, so that they can choose the best exit, and then the second best, and then the third best, based on whatever preferences are for the outbound network and also for the inbound destination network. So basically the idea here is if you can add some sort of pipe length value to the locator exchange so that the source can order the locators in the right ID. The other interesting problem here is outbound. If you have more than one upstream ISP, it's likely that your upstream ISPs might be filtering on their IP space. So if a host decides to use provider's A address, but the network decides it's best to send it out provider B may filter that traffic and drop it. So there's also interesting problem space there. IPv4 traffic engineering inbound to the destination. Destination can influence routing to determine what traffic will load inbound links. They can use an approximately shortest path, which is based on AS path, which isn't a great metric, but is useful. They can designate links as primary, secondary, tertiary, etc., using community-triggered local pref, or if it's to one AS using MED. They can attempt to share traffic across multiple links by dividing up their route advertisements. They can attempt to dial traffic around by shuffling multiple smaller prefixes across links. And they can try to bias some traffic away from the best path using AS prepending. In v6, a multi-homing destination has one IP address for every upstream ISP. If a source picks one particular address, that's going to determine what ISP the traffic gets delivered over. So we have to get the source to pick the right address. And you can do this by, once the layer 3 shim is inserted and the Shim6 handshake is complete, what you can do is you can, instead of waiting for an outage, you can immediately switch to use the upper layer ID. And you can use the clues that were sent to you so that your locators are ordered in the right order and start sending traffic down the optimum path. The problem is, prior to the shim, all of your inbound traffic is going to be based on your DNS choice. So if you have a lot of sessions that are very short-lived, the shim approach isn't really going to help you much with traffic engineering. After the layer 3 shim is inserted, though, you can simply, basically, if you can get the right clues to the source, even though he lacks BGP and IGP information, you can make the right decision. So the idea with a TLV is basically to send along additional information to the source, and there's basically 4 different approaches. One approach is to somehow get the destination to have the inbound preferences and send those along to the source. The second approach is to allow routers that are in line to insert inbound preferences to the TLVs as the shims are exchanged. So in this case, the host might not know the preferences, but the routers the host is using would. A third approach is to move the shim function to the routers itself and not do shim on the hosts, or to do shim on the hosts and do an additional shim on the routers. And the fourth solution is to have sort of an 8+8 solution where routers will rewrite the source and or the destination IP address. So one of the interesting side effects here, going back to source multi-homing versus host multi-homing, part of the problem is that the management of a multi-homing solution for Shim6 right now would be on the end host, if the end host is the one supplying this information. And this might be a difficult place to manage it. If it's a large commercial network, you've got 40,000 end nodes with the users configuring a various array of different things. They might not be respecting your network-wide traffic engineering preferences. So one of the ideas here is to go ahead and move this functionality to the router. So if you could just pick your 4 or 5 internet-facing routers, configure outbound preferences there, and then basically let the host pick whatever locators they want, and the routers will insert the TLV information here. That way you can configure network-wide preferences without having to go and touch every end host. Another approach is to have some sort of network layer server that would basically push down the policy to all of your end hosts that they would have to communicate, but this would need some sort of protocol. There's some security implications. There's a lot of concerns here. If you completely move the shim function to the routers, that'll work as well, but now the routers will have to shim every packet that goes through them, and I'm not sure that you can do this at 600 million packets per second. The other question is also, which routers do the shimming? Do you do it on ingress? Do you do it on egress, somewhere in the middle? Do you have an MPLS label stack that you need to look behind? There's a lot of issues with that. 8+8 solution was something that was looked on very early on and was avoided. There are a lot of issues with rewriting source and destination. Not all hosts may be multi-homed. It does ease the ISP filtering issue, but there are other issues that are difficult to deal with. It might break HBA CGA, which is the way that you can map a locator to an upper layer ID and make sure that you actually heard the locator from your host. It's a NAT-like solution, which I think a lot of people have been trying to avoid. The last point here also is that transit ASs might not have traffic engineering capabilities that are useful. A lot of people point out ISPs are not going to use the Shim6 approach. They're going to get their own /32, and that's great, they will. But if you're an ISP today and you're advertising anything in the routing table that's more specific than your aggregate, it's going to affect you. And that's either because you have multi-homed customers that you're going to have to work with, or because you're doing traffic engineering by splitting up your announcements. And that's not currently well, operationally it's not recommended in v6 today. So the point here is really consider the different approaches, get involved, join the Shim6 working group, read the archive, come to the BOF, provide feedback to the IETF so that we can get a solution which you guys will want to operate and which is useful to you. If you think you want to go in the other direction and you want to do de-aggregates in the routing table, that's great. Go ahead and fight for that. Talk to your vendors, find out how much memory you're going to need, find out when they can supply it for you. Make sure that you're going to have a solution well enough in time before we need it. Questions?
Where to start? Okay, this is Bill Manning, and I have a couple of, I guess, I don't know about questions, but maybe statements. Where do you find your DNS server to do your lookup?
Okay, Shim6.
Well, let me go through all of them, and then you can choose
Okay,
which
sure,
ones
sure,
you
sure.
may or
Go
may
ahead,
not
Bill.
want to answer. Right? Finding the name server by address or by name might be, you end up having to find it by address, and those things get hard coded, and that actually raises the issue of applications which depend upon some sort of bootstrap mechanism, i.e. you have hard-coded IP addresses. There's a second one which has to do with accounting. I understand ISPs actually like making money, and so they tend to track things based on generally IP address, and if the end hosts keep flipping around, this might, has anybody thought about the accounting implications of the Shim6 approach? And then the third thing was, you talk about aggregation and de-aggregation. And I would posit that your idea of de-aggregation is my idea of aggregation. I don't think there is a consistent understanding about what aggregation means to individual ISPs. So those are the three kind of things that pop out immediately.
Okay, I'm not sure if you could stay at the mic, Bill. I'm not sure I got your comment about aggregation, de-aggregation, and maybe we need to talk offline. But for the other two,
okay, let me do the first one, because it's real easy. Peter Lothberg, once upon a time, when he worked for a fairly large ISP, which is still around, decided that he was going to aggregate 192/3 and announce that to everybody else. Right? That was his idea of aggregation. Right? This would be bad. I mean, if I did 2001/6, right, and I announced that, would people be happy? I'm certainly aggregating sufficiently, but I don't think anybody else would be happy with that. So there's the idea about what that is. That's where that sits.
okay, so to address the aggregation, the whole idea here is that you want to try and create an internet where each network or each autonomous system is only making one contribution to the routing table.
No, that's not it at all. I want to be able to reach the people I want to be able to reach. That's what the internet's for.
I'm not disagreeing with you. I'm just trying to explain what the Shim6 approach is. In terms of hard-code addresses, as long as the address is still active and reachable, then everything will work fine. You'll pick the one address, you'll insert your shim, and you can switch over to whatever address you want. The problem here is in a failure case. If you've hard-coded a particular address and that upstream ISP has failed, and the other addresses have not been hard-coded, you'll never reach it. And yes, that is indeed a problem. That does not exist in v4 multi-homing with de-aggregation today. Your third question was about what happens with a host swaps back and forth. And I don't know that I'm really concerned about cost and billing, but I'm very concerned about the traffic. It's scary to think that a host might start using one address and then switch to another address, which is on another provider. And if he does that for the destination, it's going to load inbound links to the destination from one provider or another provider. And that could be a significant amount of traffic and could easily blow out links. And that's very problematic.
Hi, Dan Golding. I think Shim6 is a wonderful attempt to solve something that no one really needed to be solved, which is host multi-homing. I mean, you know, this isn't a big demand being placed on a lot of service providers to make sure that like residential broadband hosts can multi-home, even though this is something that some of the IETF folks, you know, will say that this is going to happen in the future. Refrigerator will need to multi-home or whatnot. I mean, the real requirement, all aside from the IETF's requirement documents, is for site multi-homing. That's a comment. The question is, has there been any consideration given to the level of complexity that this introduces, especially in terms of the host operating system? You know, some of our operating system vendors are better than others. And, you know, I'm trying to think about asking some operating system vendors to put in sophisticated networking code that's going to affect internet architecture into their operating systems. And I feel a little queasy. There's also, of course, the issue that do we want, you know, 5 million hackers to be able to, you know, maybe through a bot or something, or a zombie, to be able to influence internet routing. Any thoughts or comments?
Yeah, I think your point here is best summed up by something that was on the IETF mailing list, which was basically, will internet service providers want to put the cogs of their traffic engineering in the hands of end users? And yes, this is something you guys should be concerned about, and this is something you guys should be speaking up about.
Let me have a point of order here. We're kind of out of time for this session, but obviously this is an issue that people are interested in. Now, we have a BOF on this afternoon, so we can kind of make the choice right here. Do we want to spend more time and get in the path of lunch, or do we want to take it to this afternoon?
My question's really short, Dave.
Yeah, okay, that's a good one. Is there anybody here who has a conflict because we're running two parallel sessions in the afternoon who would like to make a statement now, or have a question or something now? Go ahead, Robert.
To follow on with what Dan said, I didn't notice any URLs in your presentation that ended in .tar.gz. Has anybody actually done any kind of implementation of this? I'm equally concerned about getting good interoperability with host operating systems. I remember the late 80s and plain old TCP/IP having problems with malformed packets and stuff like that, and I think this opens a really big can of worms.
This is Jeff Houston from APNIC. Perhaps if I could jump in and say yes, there is one experimental implementation being done by Francois Dupont. He's in Brittany, based on an early version of this particular protocol. However, the protocol spec is still not complete, so I would be amazed if anyone else has managed to write code at this point in time. I've been asked, by the way, to make sure that people do identify themselves at the microphone, and this is again Jeff Houston of APNIC.
All right, well, please come to the BOF, 2 o'clock, Sierra Room B, C, and D. Right here.
Yeah, that's here. Okay. All right, thank you. Stuart.